Imagine a world with no loading spinners. None. It'd be amazing, right? Think back. When was the last time you saw a loading spinner? Pull out your phone, you check something, and it just spins. Or you have your laptop open, you type something, you hit enter, and the whole interface starts to clunk and spin. It might have even been 2 minutes ago trying to load anything on the Wi-Fi here. How did it make you feel? Relaxed, I love it. Was it irritating? It's like, come on, come on, come on, I need this thing to load. Are you just resigned to these things by now? Oh, everything is so slow. What's the point? Or did it make you irritated? Were you anxious? You're trying to get back to someone. You just need to get something done, and you hit enter, and the computer says, no, you must wait. No, I must wait? Why? It makes you want to throw them all away. Phones we know are a bad idea. Let's get rid of those. But laptops too. Why are they so slow? I'd like to go back to being a simpler time. Maybe I could give up on this programming thing, be a carpenter. Because you know what's really nice about being a carpenter? You have a hammer and it sits on the shelf and it waits to you. You want to hammer something, you pick it up, you hammer and you put it back. And it waits for you. But you try that with a laptop. You pull it out, you open it up, you start typing, you hit enter, and it says, no, I'm busy. What? You're busy? You're just a glorified hammer. I have things to do. This is not an equal partnership, right? I'm the human. I have dreams, I have goals, I have friends that I'm trying to impress. But most importantly, I have stuff I'm trying to get done right now, and you are in my way. It's a problem. Let me give you an example. A couple of days ago, I was trying to join a Zoom call. It could have been any of the video conferencing platforms, but it was Zoom. And it was for someone I was trying to impress, someone who wanted to work at Zed. So I wanted to be on time. And because I'm a programmer, I'd spent every last minute debugging something else. But it's fine. The clock said 10:00. I'm on time. It's the first minute. And I go to my calendar and I click on the link and Zoom opens. And it starts to spin, right? Connecting. And the clock ticks over, 10:01, and now I'm late. I'm kind of annoyed, and I'm getting a little bit sweaty just watching this thing spin. So I kill it. Try again. I click on the link, and Zoom opens, and I see it again, connecting. And then, error. Upgrade required. Upgrade required? I upgraded Zoom yesterday. So I do it. I install the Zoom update. I join the call, but it's too late. Instead of joining on time and making a good impression, I've wasted 5 minutes of the candidate's time. They think I don't care about them, but I do. But I do. It was the spinner. It was the software that got in the way. And instead of joining the call happy and curious and ready to make a good first impression, make a new friend, I join it sweaty and grumpy and disoriented just because of this spinner. Another example. A few weeks ago, we shipped the worst bug you can ship to Zed. We broke the auto-update mechanism, right? Usually, if we ship a bug, it's not a big problem. Auto-update will take care of it before most people notice. But if you break the auto-updater, then everyone who gets that version of the software has to manually go to zed.dev, click the download link, and reinstall the new version. This is like a catastrophe, P0. And we figure the bug out. It's a really silly logic error. It takes about 10 minutes to make the fix. And we ship it up to GitHub. And we use GitHub Actions for CI, and it starts to do the build. And this is a minor one, but the first thing GitHub Actions does every time, waiting for builder to run action. We have 6 builders right here. They're doing nothing. We're just trying to resolve this outage right now. Just pick one. But that's a minor thing. We also use Rust. And so release builds take a while, right? About half an hour. And for every minute of this release build, more and more people are downloading that broken version of the software. And so I'm sitting there watching the build go, and it succeeds, which is great. And we're now 2 minutes away from resolving the outage. The last thing we have to do is send the code to Apple to sign. And so the code signing thing starts. And this is old school. It doesn't have a spinner. It has a progress bar. And everyone is watching this progress bar go like this. 60%, 5%, 70%, 75%. Boom. Internal server error. We've gone from being 2 minutes away from this outage being over to having to watch this thing spin for another half an hour. And it just distracts me, right? I can't get my work done. I'm just sitting there babysitting this thing that's going over and over and over. So we eventually get the build out, we get the release out, we email all the people that we think are using the broken version. But I go home that night, and I'm still feeling distracted. I'm feeling unproductive. I didn't get my work done that day. I didn't get what I wanted to get done. And I have 2 kids. Irene is 5, and Arthur is 3. And when I get home, they want to play with me. But when I'm feeling unproductive and distracted, I'm not good at playing with them. But they're kids, and they will do anything to get attention. And that means that if I'm not giving them attention, they start to get snippy and grumpy and angry at me. And so they're being snippy at me, and I'm being snippy back at them, and my wife has to step in and get snippy with all of us. You know those evenings, and we all go to bed at the end of the evening thinking, "Ugh, what a horrible day." All because I had to spend half an hour watching this thing spin and fail. Do you know what makes this really bad? It's all our fault. My fault, your fault. Anyone who has shipped software that is not as fast as it could be, and that is not as reliable as it could be. But I get it, right? It's hard to build reliable software. It's hard to build fast software. It requires thinking, it requires creativity and time and engineering. And most importantly, it requires good tooling. And particularly for user interfaces, the tooling we have is not good. The chances are, if you've used something on your laptop in the last couple of days, it was either in the terminal, which is really cool. I love the terminal. But if you're trying to ship a product to users who are not programmers, that doesn't work, right? Programmers love it. No one else understands it. Or it was written in React. And the problem with React, right, is it's way up here on top of JavaScript and CSS and HTML and the DOM, and it runs in this giant web browser. And if you're trying to make software that's fast, software that's reliable, you can't build it on this giant stack of things that are slow. All you can do by writing code up here is make it slower. So if you want to build things that are fast, it takes creativity, it creates time. And yes, you can do it. You can work around the platform limitations. You can do it up here. Or you can pave your own way and do it down here. But it takes time. And this is how this plays out, right? We've all been there. We're trying to plan out the next few weeks of work. And someone comes up with this amazing idea. I figured out how to make the page load take from 500 milliseconds to 50 milliseconds. And everyone's excited. Like, that would be amazing. 2 weeks. You can make the page load 10 times faster. Let's do it. But then the head of sales or someone like that will walk in and say, well, yeah, page load's great and all, but if you could just fix this bug, then I can sell this client, and then that's our revenue goal for the year. Fixed. All right. And then someone else will walk in, maybe the head of product or the head of growth. Well, yeah, page load's great and all, but like, if we can ship this feature, we can launch the new pricing, and that's going to make us get so much money. And it's really easy when you're making this trade-off of page load speed or business success. You pick business success. It's obvious, right? It takes a lot of courage to stand there and say, no, excuse me, we need to fix the page load speed. And the reason it takes courage is that it doesn't show up immediately in the metrics. But here's the funny thing. If you give someone a piece of software that's fast and that's reliable, they can use it to get their work done. They feel productive doing it. They don't even notice your software is there. They just do the thing they want to do. And then they go home and they feel happy and they have a great evening with their kids. And they wake up the next day and they're like, yeah, I get to go use that tool again, right? And that's user retention. And user retention is fantastic for business. But when you make software that's slow, software that's unreliable, that crashes, some people don't go home happy. They go home sad. And they pour themselves a drink, they go to bed, and they wake up in the morning and they go, oh, do I have to do that again today? All because our software slowed them down. I've been a software engineer, and I've been involved with software for a very long time. I actually grew up in a house with software engineers. Both my parents did the same thing. And this was, they actually had a startup. It started in our office. It expanded to the living room. It expanded to the dining room, and then we had to kick them out because there were too many of them. And this was back in 1996. And in 1996, the web was brand new, and people were super excited about all the stuff that you could build on the web. And one of the particular early adopters of the web were really fancy hotels, because they wanted you to have a way of feeling what it was like to come to the hotel without actually having to go there. And so they spent lots of time building these fantastic websites with images and animations and fonts and colors. And it was amazing for 1996 web technology, like these glorious websites. But there was a problem, which was that anyone who wanted to visit these websites was sitting at home, And at home, they had a box called a modem that would talk to the other modems at like an audible frequency. It was a very, very slow way of communicating over the internet. And so you went to these fancy hotel web pages, and it took forever to load. And if you're trying to book a trip, you might have to go to one hotel website, find out if they have any availability, and wait. Go to the next site, and wait. And go to the next site, and wait again. And so my parents realized that it didn't have to be like this, right? They could solve this problem. They could make it faster for everyone. And so they did. They started to build a website that would take all the useful information out of the hotel websites, put it in a database, and when you loaded their website, it would load really fast. And sure, maybe there's a little picture in the corner, but it's going to load in after the content that you care about. And it took a lot of time to do this. It was an investment, because this is the story my mom always tells. Every website was slow to load, every single one. She would find a new website, not from Google, because Google didn't exist yet, but from a magazine, like a travel magazine. She'd flick through, find the URL, paste it in the URL bar, hit enter, wait for the modem to start beeping, and then she'd just go make coffee. And she likes making coffee. She makes it right. It takes like 3 minutes to bloom and get the flavor just perfect. And by the time she was finished doing that and she walked back to her desk and sat down again, if she was lucky, the website would have loaded. Can you imagine that? Like a 4-minute page load time? It's crazy. But they spent the time and they did it and they made it faster. And because they had us at home, me and my sister, they did it in our house. And I can still remember I'd sneak down in the middle of the night, Mom, I can't sleep. And she and my dad would be there working on this thing, making it faster, making it better. And she'd come up and put me back to bed and then go down and keep working on it. And because they made this thing faster, they took this user frustration and they got rid of it. The company they started still exists today. It's Expedia. And I hope they've rewritten the code because it was 1996. But the problem is still there. And the solution is still valuable, which is how do you make people faster? Fast forward a long way. About 8 years ago, I started a company, Superhuman. And I started it with a friend, and the friend was called Rahul. And Rahul's one of those people that's just like larger than life. Everything he does is extreme. And so just before we started this company, he invited me to go get tea. I was like, okay. But not at a coffee shop like a normal person would have. He's like, we're going to get tea at the Palace Hotel in San Francisco. And if you haven't been to the Palace Hotel in San Francisco, it's basically the most palatial building that they have on the west coast of America. This giant stained glass arch ceilings with the columns and the flowers, a grand piano in the corner with someone playing it. And we're sitting at the tiny little table in this giant dining room. And he looks across at me and says, I want to start a company. I have a really good idea, and I think we can build it together. I was like, oh, great. I'm flattered. I've always wanted to do this. This sounds fun. But what's the idea? And he said, well, before I tell you what the idea is, let me tell you how I came up with the idea. Okay. And this was 2014. And what he had done for the last year, so the whole duration of 2013, is he'd met people and he'd talked to them and he'd asked them a question like, what frustrates you every day? What slows you down at work? What makes you feel awful about the work you do? And the answers he got were very consistent. I get too much email. Ugh, email. I have so many emails. Email, email. And so he looks at me over this little table and he's like, so we should build an email client and sell it. And I was like, no, don't be ridiculous. People are not going to pay for an email client because Thunderbird is free and Gmail is free and Outlook is free and they are all free, right? This is a free software category. Sure, we could build an email client, that'd be kind of fun, but that's not a company. And he looked at me and was like, well, I hear you, but trust me. And so I did. And we started building this thing, and it took about a year for us to get to the point where we felt like it was ready to share. And that's because every time we tried to build a feature, we wanted to make it as fast as we possibly could. And there are lots of examples of this, but my favorite one is probably search. So the comparison point is Gmail, which is our biggest competitor. And Gmail is built by Google, who are quite famous for search, right? Their web search engine is really fast. But their Gmail search engine isn't. If you go to Gmail, you type in a search query, you'll see the spinner, and depending on how fast your network is, it might take a while. Well, I don't know, packets go over the internet, stuff happens on the server, and then it comes back. And we knew that this was not going to be okay. For Superhuman, we had to have instant search. But we'd built Superhuman the way I told you not to build software. It was in React. It was in JavaScript and HTML and CSS, and it ran in this giant web browser. And if you've done any web programming before, you'll know that there's a limit to how much stuff you can store on a website. It's about 5 megabytes. And if you've done any stuff with email before, you'll know that people's inboxes range from like 2 gigabytes to 20 gigabytes, depending on how long they've been there. And it just doesn't fit. So we did a lot of research, we did some talking to people, we did some thinking, we found some ideas, and we eventually landed on, I think, the grossest hack I have ever shipped, which is that extensions don't have this limit. And so we asked every single person who used our website to install an extension, and while you used Superhuman, the extension would download your emails, put them in the extension, put them in SQLite, and SQLite has full text search. And so it was a gross hack. It took like a day or two to get the prototype wired up, and then it took like another month to try and fix all of the bugs that are caused by hacking around the platform like this. But we got it working, and it was worth it. Search was amazing. You just typed in what you want, you hit enter, and you get the results, just like that. So we've been working on this for about a year, and Rahul comes to me and it's like, okay, we have a product. It's time to start selling it. We want to launch. We want to give this to users and make them pay for it. And I was like, no. We can't make people pay for this. We've built something amazing. It feels so good to use. We should give it away for free. Let's make this open source. Let's have everyone be able to experience fast email. And he's like, no, this is valuable. Like, people will buy this. And we go back and forth a few times, and I'm not convinced. But it's like, okay, you're the CEO. Let's do it. So we pick a Monday. It's going to be a launch day. And the whole weekend leading up to that launch, in the back of my mind is this email I'm going to have to send to our investors. Like, dear investors, thank you for believing in us and all the cash that we spent. Sorry. Right? And send it back. But Monday rolls around, and we get a bunch of press. It's very exciting. We have TechCrunch and Product Hunt and Hacker News, and like lots of people sign up for the waitlist, and they start using the product. And as time goes on, I realize that they keep using the product. They keep paying for this thing. And this makes no sense to me at all, because Gmail is right here, and it's free, and it has like 15 times as many features as Superhuman does. But yet people are willing to pay for what we've built. And there's a lot of cognitive dissonance. Like, this doesn't make sense. It doesn't make rational economic sense. So I try and figure out what's going on. I get in touch with some of them, and I ask them, why are you using Superhuman? What do you like about it? What keeps you coming back? And just as an aside, if you build software, you should email your users and tell them to tell you nice things about your software, because it feels really good. But what was interesting is that I started to read the responses and really look at them. And they said things like, I feel on top of my email. My boss thinks I'm amazing because I always reply immediately. I can find anything I want to find. And what I realized is that no one said anything like, wow, that hack you shipped is amazing. Or, wow, your shade of blue is so cool. They said nothing about the software. It was all about them. And I realized that Rahul had been right all along. Because what we were selling to people was not an email client, or at least not just an email client. It was the feeling of being productive, the feeling of being good at your job. And that is something that people will pay for sure. So I don't work at Superhuman anymore. I work at Zed, as Kiara mentioned. Zed is a new text editor, a new IDE designed to make all of you feel more productive. And what's interesting about Zed is where it comes from. So the 3 people who started Zed, not me actually, it was Nathan, Max, and Antonio. And if you're into text editors and the history of text editors, you might recognize these people as 3 of the driving forces behind Atom at GitHub. And Atom was built in 2014, and it was built the same way that I built Superhuman, same era, where it was built in React and JavaScript and HTML and CSS and the web browser. But as they were building that, they realized that they had a problem, because no one wants to edit text files in the web browser. They want to edit the text files that are on their computer. And they made a decision that has changed the face of the software industry. Instead of taking the text editor out of the web browser and running it down here, they just took the web browser and they took off the little bit of stuff at the top that made it look like a web browser. And then they could run their whole web browser over here and make it feel like a native app. Right? They shipped Electron. And the chances are, if you've used software written, cross-platform software written in the last 10 years, it was Electron-based. Because the programming model is so easy. You just use React and JavaScript, and there's millions of people who can program in React and JavaScript. And so they shipped Atom, they shipped Electron, and Microsoft took note. Microsoft thought, ooh, Electron, we could use that. And so what they did is they built a text editor in JavaScript on top of Electron, and they shipped it, and they called it VS Code. And I'm sure many of you have heard of VS Code. Many of you probably use VS Code. It's very successful software. Fast forward another year, Microsoft acquired the whole of GitHub, right? They just swooped, and they became one company. But they were one company with two text editors. They had VS Code and they had Atom, and that was too many Electron-based text editors. And so they had to make a choice. And as you know, they chose VS Code, just like that. No more Atom. And this made a lot of people very sad, but the three people it made really sad were Nathan, Max, and Antonio, who had just spent years building this thing, and suddenly find themselves out of a job. Now what? So they get together, they start talking, and they start reflecting, and they look back on everything that they've accomplished. They've built Electron, they've built Atom, VS Code is there. But they realized that they haven't solved the actual problem they set out to solve. They wanted to build a text editor that made you feel productive, a text editor that was fast and reliable and got out of your way so that you could focus on your work. And if you open up Atom or VS Code, what do you see? All over the place. Loading spinners. And so they realized, hard though it would be, that they had to start again, start over from scratch. But luckily, two things had happened since they started Atom. Number one, there was a great new programming language out there, Rust, that was like production ready and good to go. And it promised fast software. It promised to build things that the executable was fast. And a borrow checker to catch all the bugs so your users don't have to run into them because it's all at runtime. And the second thing that had changed was that laptops had gotten bigger screens. And that's interesting by itself, but what it meant was that laptops also now shipped with a GPU. And if you want to build things that are fast, you want to build them on the GPU. Those things are really, really, really fast. And so they realized if they wanted to build a good text editor in 2020, it would have to be built in Rust, and it would have to be built right down here on the GPU. So they pull out their laptops, they start working, and the first step is to render a little red rectangle. This is the fastest red rectangle you've ever seen, because it wasn't even rendered in Rust, it was in Metal, in the shader language that's compiled down and run on the GPU, just like this. And then they start doing the Rust code that powers the shaders, and then they start building all the things you need to build a text editor, like font rendering and panels and panes and modals and all of those things. And because they've done this with Atom, they know they're onto something. This is feeling good. And so they start to hire a team, and they add more and more engineers to the project. And as they add more and more engineers to the project, they realize they have only solved the first problem. It's really, really fast, but every feature you want to build, you have to think about the whole stack, from down here at the GPU all the way up here to the user interface. And this is a problem. It's too slow to make fast software. So just before I joined the company, they call a feature freeze. It's like, stop. We're not going to build any more Z stuff until we've figured out how to make it productive. And so they sat and thought, and they pulled out the ideas that they'd learned from doing things in React and from building large-scale software over the years, and they built the abstraction layer, GPUi. And the role of this thing is to take the GPU and let you build stuff on top of it. As I said, this was right when I joined the company, and so I just joined, and a week later they have an offsite in Italy. And I get off the plane, I take the train downtown, this is Bologna, and I walk into this really dingy co-working space. And in the middle of the co-working space is this long rectangular table with those like harsh fluorescent lights dangling above it. And there are 8 people sitting around the table. And as I join them and I sit down, Nathan stands up and says, okay, we're all here for 1 week. We have the new framework, we have the old app, we're going to do a rewrite. In 1 week, we're going to rewrite the entire app onto GPUi. It's like, no way. No, no one ever does that, right? For good reason. But we did. We got to the point at the end of that offsite where it kind of worked. And we had a couple of things to iron out. But by the end of the second week, once we'd all gone home and had time to fix the bugs in the framework and the bugs in the UI, we had a version that we were comfortable shipping to our preview users. And by the end of the third week, we had ironed out enough of the bugs that we could ship a new version of Z to everyone. And what was really cool about this new version of Z is that it was easier to program. Of course, that was the whole goal. But because it was easier to program, it was also faster and more reliable because it was easier to change and easier to work with. It's pretty cool. Now, as I mentioned, I've been involved in software a long time now. I grew up with it. My entire career has been software engineering. And I've come to realize that speed is the #1 feature, right? Speed is the reason that people fall in love with your product, because speed is the reason that they can let it get out of your way, forget it even exists, and just work through and get the stuff they want to get done through it. And so if you can build fast software, people can go home at the end of every day feeling happy and productive and feeling great about themselves because of speed. And I used to think that slow software, there was a reason for it. Like, it was too hard to do. People had other priorities. There were other things to do. But in 2025, I don't think that's true anymore, right? Computers are really fast. We have GPUs. It goes so quickly. And we have the tools in Rust to build software that is fast, that uses this hardware really well. And we also now have frameworks that let you build things like that really easily. And I think that's very exciting. So I want to talk a little bit about how that works. The title of this talk was Rendering at 1,000,000 pixels per millisecond. And I called it that because that is how fast software has to be to keep up in 2025. If you think about your screen, it's probably a 4K display. Maybe it's even bigger, but let's stick with the 4K for now, which means it has just under 4,000 pixels this way, just under 3,000 pixels that way. You multiply those numbers out and you get about 8 million pixels on the screen. And if you have a modern computer, it's not a slow 60 hertz display. This thing wants new frames 120 times a second. So you have 8 milliseconds to give the screen a new value for 8 million pixels, right? It's a lot. It's pretty intimidating. If you set a CPU to that task, updating pixels one by one by one by one by one, I think it would melt. Maybe it would keep up, but I think it would melt in the process. And so we have to use the GPU now. We have to give the GPU a list of triangles and some scale factors and some shadows and just get it to do its thing, like multiply this stuff out, make the UI look really good. And they're really fast at that, and that is awesome. But when I'm programming and I'm building a user interface, I don't want to be thinking about the triangles. I don't want to be thinking about the scaling factors. I want to be thinking about the things that my users care about, like buttons and text boxes and widgets and that kind of thing. And so we have GPUi, which is the layer between the two. Like translate the things I want to think about into triangles. And GPUi is built on 3 main insights. The first is system integration. If you want to go fast, you have to integrate tightly with the hardware, for sure, but also with the operating system. If you use macOS or Linux or Pop! OS I learned today, they have a mechanism where the active application, the one that you're focused in right now, gets more CPU priority than any of the others. And so if you want to build an app that feels fast, you have to integrate tightly with the operating system too. The second insight is that you need a good way of breaking stuff down. So when I started programming, we used a UI pattern or paradigm called Models, Views, and Controllers, MVC. And it sounds great in theory. It's a 3-letter acronym. But it has this problem where the controllers go in and tweak the views, and the views update the models, and the models kind of tweak stuff in the controllers, and you end up with this big ball of spaghetti mess. And as you add more and more components to your user interface, the spaghetti just gets bigger. And although I don't think React were the first to come up with this, they came up with a component model that was really strong, right? A good, solid box. And the nice thing about having these good, solid boxes is that when you're working on a single component, you can mostly ignore what's going on around you, right? You're protected by the abstraction. And the extra nice thing is that once you're done building this thing, it's solid. And so you can kind of stack them like Lego. And you don't have to worry so much about interactions across the user interface because each of these blocks is solid by itself. So that's the second insight. And then the third thing that we realized, and this was the prime reason for the rewrite, was that if you want to build fast software and you want to make it easy to build fast software, it has to be written in a familiar way, right? There are millions of JavaScript programmers out there. There's billions of lines of JavaScript code. And so people kind of know how to program that way. And we didn't want to have to reinvent the wheel. And so one of the big parts of the rewrite was like, how do we make this feel more like HTML, more like JavaScript? And so we pulled in an HTML rendering engine so that we have like Flexbox and all the other cool things the web has. And we pulled in the syntax from Tailwind, which is a popular CSS library for JavaScript, so that if you've programmed on the web, you can come and use GPUi really easily. And this had a secondary advantage, which is that we then shipped this AI assistant panel, which most editors have today. And the AI was trained on the internet as of 2024, where guess what? There's a billion lines of JavaScript code to learn from. And so if we build this thing in a way that is easy for JavaScript programmers, the AI also has a hope of keeping up with you. OK, should we take a look at some code? Oh, there we go. No, where is Zed? There it is. OK, this is, apart from some import statements, a component in GPUi. Is the font size good for everyone? Great. The first thing I want you to notice is there's no macros here. This is just a plain old struct. It's a counter, as you might see, and it's going to tell me how many times I've clicked on it. And just like in HTML or Tailwind, you can see that I'm using this div here. So what this function is returning, if you look at the return syntax, is this element type, an implement element, but it's going to be an element. And elements are the things that talk to the GPU. They're the really fast bits, but we're in the level above that right now. So we're going to create an element, and it's going to send triangles to the GPU. The element we're going to create is the div, and just like an HTML div, it's kind of a rectangular shape with a bunch of properties. In particular, it's going to fill the size of its parent container. It's going to be purple. It's going to have some padding top. The text is going to be big, and we're going to have to justify this thing in the center. The final thing I want to talk about a little bit here is this click handler. In Rust, one of the problems you have to solve when you're building a component is they want to be self-referential. You want to have event handlers that update the component itself. But this is tricky to do because we don't allow circular references. In JavaScript, easy. You can just have a garbage collector. It takes care of it all. But we have to use ref counting. And it's really verbose and complicated and easy to get wrong if you're ref counting by yourself. And so if you look at this CX parameter here, it's a context of self. And context is what lets you access all the GPUi goodies, like opening windows and like screen size and stuff like that. But it also can contain a weak pointer to the current component. And the advantage of that is that when I want to create a listener, I can say cx.listener, and it knows to bind this event handler to this component. And so if you look at the type of this variable, it's going to be if I have a language server, it's the same as @mute_self. It's the same type. So we increment the count when you click it, and then we call cx_notify, which will re-render the display. And the reason you have to manually re-render the display is that we prototyped a version where you didn't have to do this, but it was too easy to accidentally update components, and that would say, hey, the screen is dirty over here, and that would cause unnecessary re-renders. And so it's much faster if you take control of which things are dirty. And so by calling cx_notify, nothing happens immediately, but the next time the frame buffer comes in, and it's like, hey, I need a new frame right now, the framework knows to re-render this component. And that's kind of it for the component. There's some stuff down here, which is the boilerplate of opening a new window. It's going to be 500 by 500 pixels. And it's going to render one of our counters. And the thing with this counter, you can see I construct one just like normal, using the Rust syntax, and then I pass it to the framework with cx_new. And that gives me back a handle to this thing that I can use to get the strong counter or the weak counter and update it or read it as necessary. And if the demo gods are in my favor, I should be able to show you a purple rectangle. But I realize I should have done this before, so you didn't have to watch the progress bar. Sorry. I'll do the loading spinner for you. It's coming. I do love the output of Rust, but this bit of Rust is it's painful. Close. Yeah, sure, and then rebuild the whole crate graph again? I don't think so. All right, we got a purple rectangle, and look, when I click on it, the counter goes up. But you know what's cool about that counter going up? There's no garbage collector. There's nothing that can make the UI go like this. It happens immediately. Before the next frame has time to render, the number is updated and on the screen. And you might be thinking, yeah, okay, it looks easy to use, but is it really? So let me tell you a story. About a year ago, we wanted to add a designer to the team. So we had our 8 Rust engineers over here around the table. And we wanted someone who could focus on the looks and the feels and not write Rust all the time every day. So we went out to search for a lot of people, and we found this guy called Danilo. He's in Brazil, and he has a great portfolio. He's a great designer. But he's also done a bunch of web programming on the side, which is great, because if you're going to be building a text editor, if you're going to be designing a text editor, you need to understand the problems the programmers have. And so we were really excited. We bring him onto the team, and I expected him to have a lot of feedback. Like, you know, you could improve this. You should be better at this. You should do this. And he did. But what I was not expecting was week 1, he joins the company, and I see a pull request come in from Danilo, just fixing a whole bunch of these bugs. And I Slack him. I'm like, hey, I didn't know you programmed in Rust. And he's like, well, no, I never have before, but it's just like the web. It was easy to understand. And you also might be thinking, like, yeah, sure, demo framework. It's easy to make a demo framework, right, that works for one component, but does it scale? Can I build a real app with this? And the answer obviously is yes. Let me put this back to Z so it's less each side. Z is built in GPUi. We have about 900,000 lines of code, not including our dependencies. It's a big app because software engineering is complicated. It's an app that solves a complicated problem. And the whole thing is built with GPUi. And that's not to say we got it all right to start with. We didn't. We've evolved the framework as we go. But it means that everywhere I go in the Z code base, it all feels familiar. It feels the same because it's all built using these building blocks, the components that we get. And so not only has GPUi not got in the way, it's actually helped us structure the code base better. And it's not just Z. We have a couple of other people already using this. One of my favorite people is a guy called Lee, who is in Singapore. And he works at a company that does stock trading, which is a very different problem from text editing. And one of the things he needed to do was draw a graph of the stock getting more and more valuable over time. And he tried to do this in GPUi, and he sent us a screenshot, and it looked awful. It was all jaggedy and horrible. And that's because it turns out in a text editor, there's only really two kinds of line you draw: a vertical border and a horizontal border. We don't do any graphs. But he was able to look at the code. It's all open source, figure it out. It's all in Rust, and make a change and put line smoothing into the shader code that runs right on the GPU, under the line. And so he did it. He had this amazing looking graph. We merged in the change. And that means that now everyone who uses GPUi has access to that code. It's amazing. And as you start to use GPUi, you might run into something we haven't solved yet. But that's okay, because you're creative. You're a problem solver. You're a programmer. And you know Rust. And it's all just Rust. And we can work together to make this thing better and better and better. And if we make GPUi better, if we make these frameworks better, we can get more and more people to the point where it's easy for them to build apps that are fast, easy to build apps that are reliable, easy to build apps that don't crash. And that is so exciting to me. Because imagine a world with no loading spinners, right? We can do this. It's going to take creativity. It's going to require some thinking, but we can solve this problem. We can let everyone go home at the end of their day feeling happy and more productive. And if we can do that for software engineers, then all of you creative people in this room, can give everyone that feeling. Everyone who uses your code can feel good about themselves. And that's really cool. So it's going to require some creativity. It's going to require some problem solving. It's going to require getting rid of this big, giant, old way of doing things that doesn't make any sense anymore. And it's going to require doing things right. So this is my request to you. Next time you're building a project, build it the right way. Build it the fast way. And make sure that your users can go home at the end of every day feeling happy and productive. Thank you.